Assalamualaikum. My name is Mama Hasbullah bin Zakaria. This video presentation is about my final year project presentation. This thesis is supervised by Dr. Siti Raizah Maksih. The title of this thesis is The Synthesis and Fabrication of Nanoparticle Loaded Hydrogel for Fiber Optic Sensing Platform. The summary of this thesis. Recent studies have shown that a structural combination of polymer hydrogel network with nanoparticles holds the promise of providing superior functionality to the composite material with application in diverse fields. One of those functionality, especially in the hybrid of hydrogel and noble metals nanoparticle, has shown that there is a substantial increase in the sensing ability of the system. Truthfully, this functionality can be beneficial to the application in the optical fiber sensing fields. It is now possible for the current fiber optic sensor to become more performance and versatile device, as the optical signal transducer could be manipulated due to the strong plasma resonance thanks to the presence of our nanoparticles. Thus, the main objective of this project is to create a novel sensing material system using our nanoparticle which embedded into hydrogels. Later, the our nanoparticle hydrogels will be encapsulated around the core region of fiber optic probe, thus creating a basic sensing platform for fiber optic sensors. Our nanoparticle will be synthesized using a chemical reduction method. Consequently, the our nanoparticle in colloid form will be mixed with polymer precursor prior to cross-linking and coated around the probe. Thus, this newly integrated our nanoparticle embedded hydrogel can be used as a sensing material, especially for fiber optic based sensors. Problem statement. There are various methods and preparation of our nanoparticles. Therefore, choosing a suitable method that can synthesize small size of our nanoparticle with a monodispersed, controlled, and stable nano shape is crucial, particularly in a sensing system. In this study, the our nanoparticles will be prepared by the chemical reduction method due to the limiting factor. Another innovation is that there is a polymeric material that exhibits the ability to swell and retain a significant fraction of water within its structure, but it will not dissolve in water. Those material is known as hydrogel, which is a water-swollen cross-linked polymeric network produced by one or more monomers simple reaction. This includes one-step procedures such as polymerization and parallel cross-linking of multifunctional. The objective. The main goal of this project is the fabrication of our nanoparticles loaded hydrogel encapsulated around fiber optic sensor. Therefore, there are three objectives that has been set up to achieve the goal itself. First, to synthesize the our nanoparticle and hydrogel materials. Second, to integrate this novel sensing material system using our nanoparticle embedded into the hydrogels. Then, lastly, to determine the result characteristic sensor of fiber optic by coating the our nanoparticle embedded hydrogel onto the fiber optic sensing platform. The scope and limitation of these proposals. The scope of this project is that there is only one chosen method for each synthesis materials, which is for our nanoparticle and the hydrogels. The synthesis our nanoparticle will be embedded into hydrogel film before encapsulating around the probe region of the sensor. Substrate reduction method is the synthesis method for the our nanoparticle, while the hydrogel is synthesized via free radical polymerizations. The limitation of this project is the lack of understanding regarding the latest update of the potential toxicity of our nanoparticle of smaller size, which is less than 10 nanometer during the synthesis, and few precaution steps are needed to be added inside the methodology. Other than that, there is time limitation in regards to choosing a biological method that requires a long preparation time, despite the recommended method which is the eco-friendly and safer approach. Methodology. On the left side is the table of synthesis process. There are two synthesis processes, which is the synthesis process of aeronautical and synthesis of hydrogels. The table is about the chemical materials that is required. On the right side is the flowchart of this entire project. Next is the method. This is the method to synthesize our nanoparticle using Turkovic method. And then this is the method to synthesize hydrogel by free radical polymerizations. This figure is the proposed hydrogel preparation block diagram. This method is to embed our nanoparticle into hydrogels. And lastly, this is the preparation for the fiber optic sensor. Expected result. We expect that the Turkovic method will be chosen to synthesize the iron nanoparticle. On the other hand, the fabrication of hydrogel will be done by free radical polymerization. Then the synthesized iron nanoparticle with the desired shape and monodisperse arrangement are mixed with the polymer hydrogel. Once the embedded hydrogel with iron nanoparticle are bound together and form image with shape as shown in the figure above will be characterized according to morphology using transmission electron microscope (TEM), scanning electron microscope (SEM), and also using UV visible light spectroscopy. By using the atomic force microscope, FAM is expected to get an image of the embedded hydrogel with a 3D crossing network structure. Under SEM image, the embedded hydrogel must be shown to be immobilized on the electrode surface with relative porous. Finally, the transmission of spectra of wavelength, the temperature response characteristic of the sensor including a broadband source, BBS, an optical spectral analyzer can finally be determined. This result spectra under strain variation will also be included. This is the expected parameter to study for this proposal. That's it. Thank you.